Okay, the fourth question is from chapter 5. Okay, so we'll do revision on chapter 5, work, energy and power. An object of mass of 2 kilograms. So we have mass here is placed 30 cm directly above the top end. So we have 30 cm here of a vertical spring. Okay, the spring constant is equal to 2000 Newton per meter. Calculate the speed of the object just before it strikes the spring. Okay, so basically in this case, okay, we have a few conditions. So the first condition is this one. So this is the first condition. So I have the bars and this is the spring. Okay, so this is condition number 1. Okay, with length here is 30 cm. And actually we have a certain height here, that is the value is unknown. Let's say we put it h. The second condition is this box is hitting the spring. So now this box is in this level. So the height of this box now is only h. Okay, so let's say the height for the first condition is h prime. So we just put it as a symbol, h prime. Okay, so answering the first question, we want to calculate the first question. We want to calculate the velocity here. Okay, the velocity here when the object is at height h just before it strikes the spring. So to solve this question, we are applying the conservation of total energy for situation 1 is equal to total energy for situation 2. Okay, we are using conservation of energy. So for situation 1, we only have gravitational potential energy, and for situation 2, we have gravitational potential energy because it has height, and also we have kinetic energy because this box is moving. That's why we have the velocity. You can straight away put the equation. So mgh prime we have here equal to mgh plus half mv squared. Okay, so to make it simpler, everything here we got m, you can cancel out. Okay, so our h prime is equal to, from this equation, g h prime is h plus 0.3 because you need to convert 30 cm into SI unit. 0.3 meter is equal to gh plus half v squared. So expanding the equation, you'll have gh plus g is 9.81 times 0.3. You bring gh to the left, so it's minus gh equal to half v squared. So gh with minus gh you can cancel out. Then you can calculate your velocity. Okay, so using your calculator, you will have your velocity as 2.43 meter per second. The second question asks us to determine the maximum compression S, meaning that we have the third condition. Okay, the third condition is when your spring is now being compressed. Okay, and your height of the box is lower. Okay, so now we have, so from this position to this position, meaning that we have a value of compression here, S. Okay, we have a value of compression here, and now our height is equal to, okay, our height of the object now is equal to h minus s. Okay, you have to understand that concept. So for number 3, we have the energy of UG and also US, elastic potential energy, and we no longer have kinetic energy because it stops when it compresses the spring. Okay, so to solve number 2, okay, determine the maximum compression. So we'll do again summation of E for situation number 2 is equal to summation of E for situation number 3. So now we substitute the values. Number 2 we have U and K. So mgh plus half mv squared, And number 3, we have mg. Our h now is h minus x plus half kx squared. So this is the formula for elastic potential energy. Okay, so we try to expand all the equations. So it's going to be mgh plus half mv squared equal to mgh minus mgx plus half kx squared. So basically mgh minus mgh, they will vanish from the equation. Okay, so now we can straight away substitute the equation, because we want to have x here. So we have, our k is 2000, x squared minus our m is mass 9.81 x minus, as we bring half mv to only one side, so it's going to be minus half 2 v is 2.43 squared equal to 0. So you realize that our equation is now being a quadratic equation. Okay, and you can press your calculator, then you can have x is equal to, your answer supposed to be 8.7 times 10 to minus 2 meter.